Hello. Yeah, last stream was also a mess with the audio at the end. Always exciting stuff going on. I have to train myself to be looking at the levels in the mic, I guess. I don't know. So today I just wanna make a quick stream here to test some components I bought. Yeah, just want to remake some oscillators. So one of my projects is to make this microphone interface. And the idea I had is to put some square wave oscillator to flip some switches. And I basically need to test this. So I got the switches and I got the oscillator. And I just want to make a few simple tests here today. This music is too exciting for Sunday morning, afternoon. So let's have an unboxing session in our program. I bought a lot of SMT components that I'm not ready to solder yet, but I'm really planning to use that eventually. This is called the LMV321 and it works with small voltages. It's kind of the reason I picked it. This is an analog switch, so yeah, I'm going to explain it a little more later. Voltage regulator. This is 555. Just thought I should have a few lying around. This is TL071 operation amplifier, also good to have around. This is something I think they sent to me by mistake. This is like a DC-DC converter, so I'll consider this like a free sample. It's the first free product that my channel got. I guess I'm really becoming an influencer. Heat shrink, that's for the first prototype of my fan controller for the Raspberry Pi. And audio cable. So the idea is I want to really connect the microphone to the mic input, which theoretically has like a 5 volt source that you can pull up to 0.8 milliamperes. So it's kind of an interesting project. I have to make something that is limited to 800 microamperes. And right now it looks like the oscillator is like maybe the thing that pulls the most current there. So right now I'm kind of looking through oscillators. I may actually have to use a crystal oscillator. That would be super cool. Like to make this microphone work like that, I need a crystal oscillator. So that'd be great for the marketing. So all of that are basically SMT components. I cannot do much with that. Like the main thing. So this is another unboxing. That's not from the mail. I walked to my electronics shop in my city. And I bought components from my friendly electronics shop. That's so cool. So that's unboxing from something I didn't receive the mail. Is that allowed in the use of unboxing? And now I'm here touching all these ICs with my bare hands, full of static electricity. Yeah. So 2 things I want to test is oscillator and an analog switch. Anymore. So it's a lot of trim pots. Just refusing to work with the autofocus. Bunch of trim pots. instant improvement to my working conditions here. Battery holder. The problem is I cannot put the second wire there now. So that won't work like I planned. Can I take this? Okay. Yeah, that might work. I'm always holding the tiny battery in two hands at the same time. With this I can eventually have like a switching. Pots. Power resistor might come in handy eventually one day. This to connect to the mic input. I'm gonna test this later. But that's a really cool component. So this is a yeah, let me just start this. More TL071. One of the things I learned at college, that TL071 is very good op-amp to have in any occasion. So just keep buying it. This, I believe, is like a comparator LM393. I'm gonna check this. Yeah. Let me put these in focus. Yeah. LM393 is a comparator, so the idea is that the circuit works basically with lots of square waves switching around. And you don't really need an op-amp for that, you can just use a comparator. And it might be slightly better in some situations, so I'm gonna play around with that. This is for making a new oscillator. So last video I was making an oscillator with 2 transistors. That may or may not work. I want to push this to higher frequencies. And it may be just wise to be relying on a circuit like that instead of transistors. The 555 is another option. Apparently there is a bit of a dispute between the 555 and the 4047. It's like Emax versus Vim. My experience, I do remember always thinking it was a little stupid with the 555. It's like there's always this extra capacitor there. What is that? I don't like that. Apparently the circuit is a little bit simpler. I just want to give it a try. Yeah, so we'll just replace. The circuit here, we have these 2 transistors and 2 capacitors. This guy can do the job with a single RC. And eventually you can use a couple of diodes in the resistor to change the resistance during charging and discharging. And then you can control the slew rate, duty cycle. Yep. And this guy, let me check if it is what I'm thinking. CDs, HEF. quite figured out the difference between these families. Something in my real expertise. Yes, so this is a 4060. For 16, so this is a quad analog switch, and it just switches like a simple switch. I'm learning there's this terminology for switches. There's the single pole, single throw. There's the single pole, dual throw also. And it's basically like one of them switches this, and the other is just switching like this. And this is what I got. I guess you can just connect multiple of them and build the other type. This is like the most fundamental. Yeah. So what's the idea of the switches? So just learned this concept the other day. A switched capacitor. Apparently this is used a lot, especially in IC design. Basically allows you to create a resistor using just capacitors. I think I heard about this a lot, but I never really understood how it worked. I'm not sure I already understand how it works. Something about this glare. Is you have the switch here, capacitor here, switch here. Let's say this is phi, this is phi prime, whatever. No, actually, yeah, so it should be. So they're connecting or alternating, alright? And this equals to a voltage divider. Okay, so basically you take this capacitor and you switch it back and forth, and this is just like a resistance. Alright, so that's what I want to try. The thing is, if you change the frequency, you basically change this resistance. It's emulated resistance, whatever. And to do that, we need an oscillator and a switch. Yeah, so the comparator, I'm not going to use it right now. I guess the first thing is just making sure this oscillator is working. So I'm just going to assemble that. Yes, indeed, a ridiculous mistake. I apparently don't know what's the pin numbers anymore. See, that's why I have to get back at electronics. Now I'm gonna turn on. Yeah. So it works when you connect the wires to the correct terminals, it tends to work. Let's plug a second LED here. So this IC, it gives you with the negated output. I think that's gonna be useful for me actually. Oh, I guess it's very useful in general. Cool. Now you can see the LEDs blinking one after the other. Nice. There's another output that's interesting. Check on the data sheet. 10, 11, 13. Church bells are ringing. It means it's time for lunch. Almost finished it. Just gonna take this other output. There's a bunch of LEDs. Just move these guys around. Wow. Out of here. More space now. Ouch. Yeah, just want to show that this third output brings a different frequency. It's like a little clock, and the other ones that like switching to this clock. There's some flip-flops around that use the trigger on the edge going up or whatever. Okay. Yeah, there we go. That's a 4047 oscillator. And that's cool. I want to see now if I can pull the high. I want something like 100 kilohertz, 1 megahertz maybe. And because I'm going to be chopping some audio signal, so it should be the frequency much higher than say 10K, alright? Yeah. I guess that's it. I'm gonna have my Sunday lunch now. See you later.